Hello my dear students, welcome to another session of virtual class. I'm Alimuzzaman, your subject teacher, Department of Physics, Milestone School and College. So, let's start. Today we are going to discuss about chapter 6 and our topic is board question solve. So today we are going to solve Select Board 2019 and Rashi Board 2017 from chapter 6. Okay my dear students, here is the credit question of Select Board 2019 from chapter 6. The credit is the distance of two electrical poles is 50 meter and in summer season the temperature of air 30 degrees Celsius. These two electrical poles are connected with copper wire of 50.033 meter length. In winter season, the temperature of air is 5 degrees Celsius. Here is a note that the mass of copper wire is 30 degree and specific heat of copper is 400 joule per kg per Kelvin. The question C is how much heat energy is given by the copper wire in winter season. Okay, so again I repeat the question. The question is how much heat energy is given by the copper wire in winter season. And question D is in winter there any kind of possibility of tearing off the copper wire? Analyze mathematically. Okay my dear students, now we are going to solve question C. Okay my dear students, so we are going to solve the question C, which is how much energy is given by the copper wire in winter season. So my dear students, we have in our hand mass of copper wire M is equal to 30 kg and the temperature during summer theta 1 is equal to 30 degrees Celsius. Temperature during winter theta 2 which is 5 degrees Celsius and specific heat of copper S is equal to 400 joule per kg per Kelvin and we have to find out the rejected heat. So there is no conversion of the states, so the formula is, we know that the formula is Q is equal to ms del theta. So del theta is change of temperature. So my dear students, before putting the value we have to distribute the formula. Ms del theta is equal to theta 2 minus theta 1. No doubt the temperature is going down, so the resultant heat is minus here, but the product is rejected heat, so the answer is in positive form. So no need to tension about that. Okay, so N is 30 degree, S is equal to here 400 and theta 2 is equal to 5, theta 1 is equal to 30. The unit of heat is equal to joule here. So the answer is minus 3 into 10 to the power 5 joule. So here is the answer my dear students, which we are find from the equation Q is equal to ms del theta. So the answer rejected heat is 3 into 10 to the power minus 5 joule. So my dear students, here is the answer of the rejected heat by the copper wire during the winter season. So now we are going to solve the question number D, which is from Creative Select Board 2019, which is in winter there any kind of possibility of tearing of the copper wire? Analyze mathematically. So is there any possibility to break down the wire? We have to find out that. And we have to find out the length of the copper wire during winter and with comparison summer 50.033 meter, we can find out the possibility of breakdown. So my dear students, here we are applying the formula. We know that the formula of linear expansion alpha is equal to L2 minus L1 divided by L1 theta 2 minus theta 1. Then alpha L1 theta 2 minus theta 1 is equal to L2 minus L1, and L2 is equal to L1 plus alpha L1 theta 2 minus theta 1. Now we are applying the values. L2 is 50.033 plus alpha 16, which is linear expansion coefficient, 16.7 into 10 to the power minus 6. Here is the information we take from the stem. The length of copper wire during summer, we already know that 50.033 meter. Then temperature during summer, we already know that 20 degrees Celsius, and the temperature during winter theta 2 is 5 degrees Celsius. Linear expansion coefficient 16.7 into 10 to the power minus 6 per degree Celsius, and we have to find the length for comparison during winter. Okay, so here is the value for alpha, and 50.L1 value 033, then 5 minus 30 for temperature. So what will be the result? The result is 50.012 approx meter, which is less than our length in summer. So there is no opportunity to break down the wire during winter. Okay, my dear students, whereas it is less than 50.033, so there is no possibility to break down. So we can write here, there is no possibility of breakdown during winter. So here is the answer for question number D. So now, my dear student, this is the question of 2017 Rajshari board, which is a figure, a metal pieces figure. The surface area of the figure increased by 0.1 meter square for range of temperature 30 degrees Celsius. So my dear students, this is the question C. Find out the coefficient of linear expansion of the metal piece. And D, what will be the increase in temperature to increase the surface area of that metal 6%. So now we are going to solve the C, and for that we have the given information, that is length 4000 millimeter, which is 4 meter, width 3000 millimeter, which is 3 meter, and the temperature increase del theta is 30 degrees Celsius in Kelvin, also 30 degree Kelvin, and increase initial area A, which is length and breadth as 12 meter square. Okay, so increase of area also given in this term, which is 0.1 meter square, and we have to find out the coefficient of the area expansion beta for linear expansion alpha, because we know beta is equal to double alpha. Okay, so now first the formula is, we know that beta B is equal to del A divided by A into del theta, which is putting the value after del A 0.1, A is 12 and del theta is 30. So after calculation, result is 2.77 into 10 to the power minus 4 per Kelvin. Okay, so per Kelvin. This is the answer of beta, which is the area expansion coefficient, and we have to find the linear expansion coefficient for our question number C. So for that, the linear expansion coefficient alpha is equal to beta divided by 2, which is 2.77 into 10 to the power minus 4 divided by 2, which is 1.39 into 10 to the power minus 4. Okay, this is the answer of question number C. Now we are going to solve the next section, which is D. So my dear students, for question number D, now I'm going to apply a short technique which will be more fruitful for this section. So my dear students, we have to find out the increase of temperature or change of temperature. So we can use the formula of area expansion easily here, as we know that beta is equal to del A divided by A del theta. So here the given information is increase of surface area. So increase of surface area is equal to del A divided by A, which is 6%, as numeric value is 0.06. So we are going to apply the value directly here as for this section. So del theta is equal to, or del A into 1 by beta. So the value is 0.06 and beta is 2.77 into 10 to the power minus 4 from C, and the resultant value is 216.6 degree Celsius or Kelvin. Basically the result in directly Kelvin, you can write it as degree Celsius for increase of temperature. So my dear students, here is the answer for question number D. You can solve this answer also in your way, but I think this is a tremendous way to solve this section, as you can solve without any value, without any data from the split method. You can find out the value of volume expansion if you have the rate of increase of volume as percentage. So this is a shortcut technique for this session. So my dear students, this is the end of this session. Hope we are going to meet in our next session with a new lesson. Till then, bye bye.